we're 40 minutes into our 2-hour session, and we haven't gotten through the summaries here yet. That does not bode well. We were doing so good yesterday that I'm a little concerned right now. So what I'd like to do is kind of speed things along. If there's something critical, Brian, you want to say? I mean, I think we could probably, this is an argument or a discussion, let's say, a passionate discussion that's been going on for at least a decade or two, actually longer.
Just make a quick point that gravity tractors were promoted mostly for avoiding keyholes, which are for using very precise motion to guide yourself through a nest of keyholes, and not for general purpose deflection.
Right, but again, with this enhanced mode, it may be possible to extend that applicability past keyholes.
Well, the amount of mass that you need to pick up is much larger than the demonstration that's been proposed, which is pick up 20 tons, which really doesn't do you much good. You need to pick up 1,000 tons or tens of thousands of tons.
Well, again, we have to remember that this is a demonstration of techniques. It doesn't have to be the final actual implementation, and certainly...
Well, but if it's not really relevant, no one questions Newton's laws.
Okay, so I'll just comment that 20 tons is not necessarily the maximum that can be picked up. Upward of 200 tons can easily be picked up with the ARM or the ARV spacecraft as it's currently proposed. Now, whether or not you can get that back and return that as part of the ARM, that's another issue because of the target selection. But in practice, 20 tons is by no means the limit.
Okay, well, you use the term easy, and I need to react because we've been working on Comet surface sample return for all of my career, and no one thinks that's easy. Even picking up a few grams is not easy.
I don't know if I said
believe
easy.
you used the term easy.
If I did, I didn't mean to imply that it's...
We need to move on.
Yeah, I didn't mean to imply that it's easy. There's obviously technological challenges and engineering challenges, but it is possible. So, yeah, let's go ahead and move on. Josh isn't here. I think we got this one, and I'm sorry, Jeff and folks online. This will be a lag in the Ustream. Okay, we were on this slide, I think.
Yeah, and the reason I originally came to the mic was not so much to fix slide 2, which sort of started some crazy cascade here, but and we don't need to do it now, but the general focus of that presentation was on the OSIRIS-REx incarnation of a low-cost deflector. Should be somehow captured there.
Okay.
Don't want to do it now, but.
How about this? How about implemented for a large near-Earth asteroid using the ARV as the observing spacecraft? And I could actually, let me. How about this? Because this was the bulk of the presentation. This mission concept. Is that better? Does that work? That would have been easy, Steve. No, good. I mean, all this is good discussion. Please don't get things wrong. Okay, so now actually, I think we're still okay. This is what Paul, Pat, and I pulled together from yesterday's discussion, and this is all open for editing and tweaking. And but what we try to, first of all, we want to capture the key topics discussed. We certainly can add a page here for what gets discussed this morning. If we haven't captured anything. And since I'm not keeping notes over here, I'm going to rely on Paul to make some note of something that we need to capture. I think there was a lot of discussion, but I'm not sure at this point. we need to rehash that. But basically, it was pointed out yesterday, I led off with this, that there's kind of three classes of demonstrations. Deflection demos with little or no additional costs. So basically, the idea is the use of the ARRM assets. So we don't have, at least minimally, modification or changes that would affect that. There are deflection demos with additional costs. Those, for example, would be a kinetic impact, solar collector, microsatellites, et cetera, things that are not currently in the planned approaches and would result in some incremental cost. It might be small, it might not be that large, but it would be something. Maybe a little, the first one says little or no, so the emphasis there is really on minor. And then the third class of demonstrations, and maybe I should qualify this, presented, just to be completely clear, were demonstration of devices that are applicable to future planetary defense approaches but are not deflection demos based on the ARRM concept. So, for example, a transponder right now is not in either of the ARRM concepts, but could be applicable to planetary defense if we did decide to incorporate one. Second bullet captures Andy's comment, and I think we can all get behind that. There's potential to combine approaches and techniques to provide a more effective or comprehensive demonstration, if it makes sense. In order to implement deflection demonstrations, analyses of the time required to develop necessary technology should be performed with respect to any impacts of the overall ARM mission budget and schedule. And I don't remember who stated that yesterday, but I want to make sure, I hope we captured that accurately. I think that is what was conveyed. Makes sense. We don't want to stick something in the ARM mission that ends up causing a programmatic issue, problem, slip, additional cost, etc.
So impacts on instead of
Yep. Thank you. Enhanced gravity tractor, ion beam deflection, and post-mission kinetic impactor using the ARV and return mass were all considered as deserving further study for the ARM mission.
Need to add an L to the defection.
Oh, defection. Thank you. Good eyes. It's funny how you can just see what you want to see.
It's not and return mass, isn't it? It's like and or.
Well, the post-mission kinetic impactor, yeah, it could be an or. Yep, you're absolutely right.
Or maybe, well. Yeah.
With or without.
Yeah, right.
Good catch, because we could.
Or and perhaps the return. It's always the ARV probably, but it couldn't necessarily always be the return mass. Yeah, that.
About that. I should be able to get this back up a little bit. There you go. No, that's a good point. Again, just to make sure it's clear to everybody in the audience, there is a separation capability on between the capture mechanism or capture system and the set bus, so that whatever material is brought back can be jettisoned either for an emergency or, if it's desirable, to repurpose the SEP for something else at the end. And if we're low on propellant, which is likely, we probably wouldn't have enough propellant left in the tanks to push a large mass out of the lunar distant retrograde orbit or wherever we have it at the time. Okay. Capture the discussion about the incremental improvement that Bong Wee brought up with respect to kinetic impactor navigation, and that is incremental improvement in kinetic impactor navigation accuracy is needed to be effective against smaller near-Earth asteroids, but this can be mitigated by observer spacecraft at target. I don't have. Oh, B. Thank you. I said it, right? Yeah.
I think there's a point relative to that needs to be made, which is that people have proposed, of course, taking large rocks and using them as kinetic impactors. But if you look at the delta V in the terminal phase of deep impact, they had 25 or more meters per second of delta V right at the end available. And I don't think anybody believes that we can do that with 1,000-ton or, rock we pick up. So, so the proposals that call for using in situ rocks, in situ mass from asteroidal mass as kinetic impactors need to really think hard about that terminal guidance phase.
How about particularly for mass augmented impactor?
So,
For example, 500 plus tons?
I think Brian's absolutely right that's a very difficult problem engineering-wise for using the asteroid as a projectile. On the other hand, I think, and I'd like to know if Bongwi agrees, this is something, a technology demonstration that is the terminal guidance, rather than a technology development. We know how to do the targeting, and there's not a technology development issue that should be raised by this. It's just a matter of demonstrating the capability. I don't think there's a development issue. So that as it reads right now, it looks like we're not sure how to do it. I don't think that's quite right.
Okay.
Yeah, I agree that somehow the navigation guidance or targeting issue is a demonstration, whether we can do it or not. Also, for the realistic situation, we will not have observer satellite rendezvous and waiting for impactor. So somehow we have to adjust it depending on, are we talking about flight a demonstration or technology to be used in actual situations? So.
Yeah, but that's still not clear. We could end up having an observer spacecraft. We could have a very small satellite that's sent out beforehand that helps provide accurate orbit knowledge so that we can improve the accuracy. It may be critical to have that. Again, depends on warning time and when you apply it. So, if I restructure this as sub-bullets, does that make it better so it's not all in one thought? I think the key, and maybe here, what Bongwi was bringing up, tens of meters. When he was saying it, is we did.
But as it's written now,
Use the microphone, Steve, sorry.
I read it to say that we need technology development, and I don't think that's right. So I would just say that demonstrating improvement is needed, not developing. There are a lot of folks who think that we don't know how to do this, and I don't think that we should be reinforcing those misconceptions.
Okay, so how do you suggest to be worded? Demonstrate improvement? Or demonstrated improvement?
Demonstrating the capability.
Yes.
Yeah, right, demonstrating capability. Yeah, right.
For higher accuracy.
About demonstrating adequate navigation accuracy.
That's great. Demonstrating adequate navigation accuracy for kinetic impactor.
Who's this? For kinetic impactor against smaller NIAs, that might work.
How about that?
And Dan, got a comment on the second sub-bullet there where you're editing right now.
Okay.
The problem with a high mass impactor is not the accuracy, it's the impulse you have on board and the amount of, the amount of propellant and the amount of thrust, because you may have to do
Right.
big maneuvers late. And I
Right.
don't think that belongs as a sub-bullet under accuracy. It's
Okay,
a
so-
completely different engineering concern.
Yeah, no, it is, and it was not.
You might solve that just by saying, terminal phase maneuvers for mass augmented impactor or something like that, because it's not an accuracy problem. It's a impulse problem.
Okay, let me see if we can backtrack. No, I think it just belongs as a different bullet.
I agree.
Yeah, I was just thinking, I was just trying to see if it was somewhat. Say, so.
Terminal phase maneuvering for mass augmented impactor, and leave it at that.
Terminal phase maneuvering for mass augmented kinetic impactor. What size? How do I get, does anyone remember how to get, oh, it's this thing, right? Yeah, there we go. Okay. I'll clean this up. All right. Let me pull this down a little bit, see if it gets bigger. All right. Comment? Go ahead.
I'm sorry. On the first bullet, the first sub-bullet can be mitigated by observer spacecraft at target. What would be an example of that? Maybe I'm just a little confused with that.
I think you can drop that.
Drop it, just leave it alone.
If you know the shape, it helps, but it's really not that big.
Okay.
Okay.
I thought it'd be more confusing if you kept it, but I agree with you.
Yeah, so more accurate orbit determination of the target you're trying to hit is not that helpful for that terminal phase?
Well, once it's in the camera.
Okay.
I mean, I think that with a 500-ton spacecraft, if you had somebody already there, then the terminal phase gets to be a lot easier. But I think this is fine.
Okay. So we could turn it around and have it as part of that bullet, is what you're saying?
Yeah, sure.
Let me see, did I lose it? I keep hitting the function key on this keyboard. Okay. I think I can do this. Okay. I'll clean up spacing and stuff, just make it a little bit more readable. The next one is deflection demos need to be binned into the ARM or the grand challenge to make sure that ideas are not discarded due to near-term budgetary constraints. Is there a typo? No? Okay. I think that captures the discussion there and what Steve brought up, and you'll see we've got it binned into 2 in the findings part. Demos don't need a large deflection to prove their effectiveness. For example, a few tenths of a millimeter per second. I think Tim made that point, and others.
1/8, yeah. I mean, clearly you have to be observing that, or the number's much, much larger. But I don't know, I mean, if that's obvious enough, we don't need to say it, but.
How about?
You're basically saying it has to be enough. Well, no, you have to be there to measure. If you're not.
Use the microphone, please.
Yeah, if you're not there, then that number is much, much larger. So. Well, it is. They hit it. The spacecraft went away, right? It's not a very good demonstration.
If observing spacecraft, how about?
Well, actually, you do. If you miss, then the spacecraft's still there, and you can download tons of telemetry and say, "Oops," But if you get a glancing blow, then you don't know why, and
Dan,
How about that?
Sure.
No, that's a very good point.
And Dan, we have a couple comments. Some we may have addressed these, but I wanted to couple comments from people online.
Okay, good.
So Rob Mueller asks, please tell Dan to capture broader planetary defense ideas under the grand challenge, even if they don't meet the ARRMM. So I think we're doing
We
that.
got that.
And then another one from online. My personal feeling is that direct push has been too neglected, gravity tractor too emphasized. So it's a comment.
Right, and so that, we had that discussion a few minutes ago. We'll see if we capture it in here. I think we actually may need to add that. So what I'm going to do real quick is copy this slide so we can add that one. It's interesting how you can't use a keyboard that's a little bit different than your own. Okay, so we're going to go up to 3 of 3 on key topics discussed, and let's capture that one right now. And I apologize to the folks that are online. Sausage making with PowerPoint is probably very painful with a 15-second delay. So let's capture that. Read me that one again.
This one was the direct push has been too neglected, gravity tractor too emphasized. So I think just some emphasis or some acknowledgement that direct push needs further analysis or further investigation.
What is direct push in this case? Is that the ion beam, or is that the anchoring and thrusting? I'm not sure what it means.
I think it's not clear from this, but it could mean all of those. So I would take it to mean direct interaction with the surface, which is another point that we had down here.
Yeah. How about let's call it out, and if whoever online made that comment,
I would leave it like that, Dan, just because I think that's my interpretation of what they mean.
yeah, unless we hear otherwise. So I'm going to say approaches. Let's be explicit here. Deflection approaches that utilize direct push by interacting with the NEA surface need further assessment to determine their effectiveness.
And Dan, just a time check, we are at 9:05.
9:05. Okay. So I think we've captured that. All right, going back to here, captured the comment that planetary defense demonstrations can be performed on very small, less than 10-meter NEAs, but they are more applicable to larger 100-meter plus objects. More relevant? Well, I think relevant's the right word. If I mean our current understanding is that below quote unquote 30 meters or 20 meters, typically they're not a threat. So, and Chelyabinsk may be that example of that unique such and such a sigma event that size caused a ground effect.
I mean, you could just say, but actual threats are larger NEAs.
No, I think I like the wording the way it was.
Because that's is that a telecom line we got?
So,
we just lost?
Yeah, we lost.
Okay.
so
Okay.
So Dan, the clarification was, direct push equals anchoring and thrusting.
Okay.
So I think we captured that.
I think we got it.
I think
Okay.
interacting with the asteroids.
Is this where you want to capture sort of other?
Can you use the microphone, please? Sorry, people online.
Yeah, hang
will
on.
not be-
Let me do this last one on this page, and then we'll go to the new page, and then we'll get. I think after that we've got findings. I got findings and nuggets, and we can walk through that. But no, go ahead. Go on, microphone. Let me just do this one real quick. So I captured 3 other ideas that were discussed. They were just kind of mentioned. Not a lot of discussion, I don't remember if it was you or Andy or a combination, but an ESPA-based SEP module as an idea, use of the launch vehicle upper stage for impactor mass,
Yep.
and solar sails for passive deflection. But there's just, there's no meat on those bones.
Well, there's a few other things you could do. For the impactor, you could have subsats, CubeSat-like, that you could have some delta V and send them out ahead of the main vehicle and use that to refine, sort of like they do with phalanx. They have tracers, and you refine your trajectory based on the success and the of those.
For kinetic impactor?
Yeah.
So I think we kind of answered that
Okay.
we probably, if we were going to do a kinetic impactor to a target with a certain orbit knowledge, that we wouldn't necessarily need the observer spacecraft or some recon satellite to help that.
Well, this would be subsats on that satellite. Anyway, don't worry about it.
Okay. I'm trying to understand.
It could be useful in some cases, I suppose, but.
Yeah, but it's not necessary. So I think situational awareness, observation, PR, all that is always good to have. So I think that's kind of understood. If you could come up with a concept.
James Cameron was going to do this mission to the moon, and he insisted that there be two satellites,
Right.
two landers, one that was the actor and one that was.
Absolutely, as any good director would do.
Yes.
You want it on film.
And JPL has a requirement that you have telemetry all the way in, and so you basically want to have confirmation anyway.
Yeah,
I didn't come up to make that comment.
I think that's probably in the weeds here in terms of the bigger picture. So we've got this last key topic that we just added, and let's tell you what. Let's get through all these, and then if we want to come back and have some more discussion, this is all good discussion. If we want to add something, we've got a page here to put it, and I can go back if something comes up and put it as a quick parking topic, or Paul can jot it down. So. And I don't know how we're going to get through this in 15 minutes. I'm probably going to jump directly to the findings for the plenary session. But let me just show you what I've got. We've got relevant findings. There's 2 pages relevant to the asteroid redirect mission. Don't try to read it yet. Findings relevant to the grand challenge. And then I've got 2 pages of nuggets that I pulled out, just things that that I put down in my notes. Then we can walk through those real quick. So that's where we're at. We got 50 minutes to do this, and add anything else.
Can we just throw out a few other ideas?
Sure, go ahead.
I thought there was a consensus on containment of the asteroid as being critical, so you don't lose, don't leave a trail of material across the.
I don't think that's a consensus.
Okay.
I think it could be desired, but we don't know enough about. Are you saying for the retrieve an entire one?
Yeah.
Okay, so yes, there is, but I don't think we need to capture that in this. I think that's been captured in the capture system, other sessions.
And then the other one was the fact that in-track gravity was tracking was the preferred approach, and that was said multiple times.
Yeah, and so I don't think I agree with that. I wanted to come back to that statement. I think it's actually probably, if I had to guess, or if I had to give my opinion, I think it's the exact opposite, because the in-track, you have to cant the thrusters away, which gives you cosine losses in order to not plume for the gravity tractor. Going into this halo orbit, this spiral orbit. Did I miss the point of the discussion or the comment?
This is the direction that you're trying to push the asteroid with respect to its orbit. And which approach you use, I mean, doing the orbit thing around it is fine. There's no issue with that.
Oh, okay.
This is just, the thing is that if you have a long time, you want to do a period change. If you have a short time, as you said, you can move it sideways, but generally that means you're doing an impactor anyway. So for slow stuff, you generally always want to do period change.
I don't think that needs to be, I mean,
I think that's pretty
think we need to put that down there, sorry.
Yeah, the notion that you want to push along or against the direction of travel of the asteroid to get the most deflection for, if you have months, more than months of warning time, that's 20 years old.
Yeah, yeah.
It's been known for a long time. There's
Yeah.
a paper by Clark Chapman and Tom Ahrens, I think.
Yeah.
on that.
I think it's
Excuse me,
less. Go
Alan
ahead.
Harris. So that goes back to like 1993 or something like that. I just want to correct a misconception, though. The Halo Orbit gravity tractor has the same cosine laws. The thrust vector, the thrust isn't canted off, but the spacecraft is pulling sideways.
Sideways,
in
yes.
addition to forward, and all the sideways is cancel out, and all you're left with is the same cosine theta. So I think it's the same ball of wax.
Correct, thank you.
Okay. Remember to use the microphone, please.
Yeah, yes. Yeah.
Please, remember, audience comments, please use the microphone.
Yeah, Stan, no, that is a very good point, unless, of course, the cant angle of the thruster is different than the angle that the orbit makes with respect to the asteroid.
Yeah,
So,
it all
but
has-
you're absolutely right, that's not the main
It
driver.
all has to miss the asteroid, and it all depends on the divergence angle of that ion beam. I think it's going to end up being the same cosine theta.
Yep, you probably are correct.
Okay.
Yep. Is there a comment, or can we,
New topics, or yet? Not yet.
oh, for discussion? Okay, yeah, let's do 5 more minutes of this, and then let's get through the slides. Go ahead.
Okay, so I wanted to bring up something new that maybe we want to address, maybe not. People may not, Marshall Eubanks here, by the way. People may not be aware, they might not have caught, I posted this on Twitter yesterday. The U.S. DOE, which is our nuclear people, and the Russian Rosatom, which is their nuclear people, signed a memo of understanding back in September on, among other things, defense of asteroids. Now, if you know anything about these people, when they say defense against asteroids, they're talking about sending nukes against them. And I would dare say that probably no one in this room has had any contact with any of those people about any of this. I know I've asked around and most people don't even know about it. And to me, that's something that should have a flag raised. I mean, I would.
Yeah, I hear you, and I read
It's not connected
I read the
directly
documents, but I'm
to the
not
arms,
sure it's
certainly.
relevant to this discussion right now. So let's,
I think,
I think NASA headquarters is aware of it. I'm sure Lindley Johnson, for example, is aware of it. But I don't think it's relevant for this.
I think at some point scientists
topic.
and engineers here have got to say, hey, this could be cool, but you really need to coordinate with us, contact, 'cause
So-
I think the expertise is here, not there.
so I think what will happen is that I think Lindley is aware of the situation, and we'll make sure that that's taken up through headquarters and.
Yeah,
and
so
actions
let's
taken.
hold that. There may be a little parenthetical we can add to one of the comments later on that may be applicable or apropos.
I just wanted to bring it in front of people's attention,
Sure.
what you do with it.
Yeah, no, and folks should be aware of that.
You can't have a global discussion of grand challenge asteroid response without saying nuclear is an option, and then you just leave it. But I mean, I don't think you can just completely throw that off the table.
I don't think
some of the.
Yeah, we weren't throwing it off the table.
Yeah.
Okay, so even though we didn't talk about it in this session, and I mean, some of the impactor stuff, as Bong was saying, are relevant to the nuclear side of things, and so they help.
Yeah, no, I think that's right. It's just that I don't think we need to start talking about how we interact with other agencies and things like that.
Yeah. Okay, so again, we got 45 minutes. Let's go through the relevant findings. And I know Chris Moore, and Chris is probably not in the room, but, oh yeah, you are. Chris is looking for recommendations. And so I think we're couching these as recommendations. I don't know if we have, didn't use the word necessarily recommend except in some sentences, but we can see if we need to word it more strongly. But basically, the enhanced gravity tractor, ion beam deflection, and post-mission kinetic impactor using the ARV return mass, for example, placed in lunar vicinity, were all considered as innovative concept with potential benefits. Likely to be the lowest cost demonstrations with relatively minimal additional technology development identified. Comparison of relative effectiveness, risks, and applicability to small NIAs and large NIAs needs to be assessed in a consistent manner. We've got different studies with different assumptions, but these were the three that I think that the group can, in consensus, can say are probably the lowest cost planetary defense techniques, because we have in essence, we have all the stuff. We don't have to do much. We may have some difference in computer algorithms. Obviously, if you do the post-mission kinetic impact, if you have a large mass, we may not have enough propellant to do that, so you may jettison the mass.
Yeah, you got a defection on the top line there again.
Another defection.
Yeah, going over to the enemy.
I will do a, could you put a little note to do a word search on defection versus deflection?
You want to make the same comment about not necessarily with the return mass, using the ARV with or without return mass?
Yep.
I'd just like to point out that of the three options there, one is relatively easy and two are relatively difficult. And so I'm not sure lumping them together really makes sense. Picking up tons of mass is highly non-trivial. And maneuvering, late stage maneuvering, even if it's just the ARV, the ARV was not designed as a kinetic impactor and would be very difficult to provide that 25 meters per second of late terminal. Well, we got 22 Newton thrusters right now, which is not enough to really do that job. So the ion beam deflection is a straightforward thing to do. The other two have serious risks that would need to be addressed.
Yeah, so that's where I think the comparison of relative effectiveness, risks, and applicability captures that.
Well, that's a soft way. I mean, it all three sound co-equal in the main bullet, and then you go, oh, well, and we need to look at risks, and that's not really true.
Well, I hear you, and I get that's your opinion. I'm not sure that we got enough data on the ion beam deflection at this point to know all of that. For example, and collecting a multi-ton boulder, how risky is that versus capturing an entire small one? There's a lot of risk in there that has to be understood further. So I don't think, I'm going to open it up to the floor, but I don't know that I heard enough that would necessarily isolate the ion beam deflection as the number one approach. But
it's certainly ripe for demonstration. It looks pretty impressive on paper, and then it's a great demonstration topic. I think maybe what's sticking here is the word minimal in the first sub-bullet. That I don't know that that's necessarily true for enhanced gravity tractor if we're trying to collect a lot of mass. But if it's part of a pick up a boulder, perhaps it's part of the baseline, and the kinetic impactor using the ARV without the returned mass is certainly modest. I think the one big technological gap there would be having enough mass on your ARV with the massive asteroid.
Yeah, but what if the mass of that ARV is, instead of 10 tons, is 50 tons or 30 tons, not 500 or 1,000 tons? So with the alternate approach of pick up a boulder, you're not talking about maneuvering a 500-ton net mass necessarily. You have your choice. So again, trying to capture both approaches in there, I thought it left it fairly agnostic and not choosing, since I don't think we clearly have a good apples-to-apples comparison at this point, based on the RFI responses. I think they're all worthy of further investigation.
I mean, I guess I would say that, to my mind, ion beam deflection demonstration is a slam dunk. Everything else has, minor issues with it that need to be explored. But ion beam deflection, I think, you can motor up to the thing and just do it. And I don't think there's any issues there that people are generally worried about.
Okay, so I'll give you the issue actually for the alternate approach why we have not considered it so far. And that is because of our desire to minimally affect the ARV, which right now does not have opposing thrusters. And for a large asteroid where you're doing a boulder pickup, you have a series of slewings that you have to do. You don't have the ability to maintain position for the ion beam deflection maneuver. So for the alternate approach of pick up a rock, it is not a slam dunk. And since we are already picking up a rock, it's not as clear cut. For the small guy, for returning an entire small one, it may be a slam dunk. Well, it is, because there is no choice to pick, well, I guess, no, there is no choice to pick up part of it and do the gravity tractor there, except with the spacecraft itself, the enhanced gravity tractor.
I just want to make a quick comment. I think it's my personal view, ion beam deflection concept approach was somewhat oversold without any technical evidence, and that vehicle concept has nothing to do with ARV. Am I correct or wrong? Ion beam deflection concept, approach, satellite, whatever, is not related to ARV.
Well, the ARV, because of the fact that it has an ion propulsion system.
I know, then
it can
it should be called SEP. We are here to talk about possible application of asteroid redirect vehicle. That's our scope here.
Right, and with the current reference ARV, we can demonstrate the ion beam deflection.
Right. Yeah, so I think that statement is exactly wrong, which is to say that you can do a very nice demonstration. You have to thrust on the asteroid for a period of time of order an hour before you get too far away. Then you do a flip turn and you thrust in the other way for about an hour, and then you do it again. And it's,
Right.
that's not that difficult to do. Furthermore, at this stage in the planning, you could put the collimated gridded ion thruster that John Brophy described yesterday as part of the mission, which would add cost and mass. But, without, it's relatively minimal. So in the
Right, so we have
in keeping
not.
with your term relatively minimal, those thrusters exist. They've been developed. They're not really a technology risk.
So I'm missing the point, Brian. What do you want me to?
Well, you made the point that these maneuvers that would allow you to use the single thruster of the existing baseline arm vehicle, to do the ion beam deflection. We've looked at that, and I just believe that's not true.
And you've looked at that for a large target as well as a small one?
Well,
Again, right now, there are two approaches on the table, so I'm trying to be
Well-
encompassing of both of those approaches.
2 newtons of thrust. If you have a huge asteroid, 2 newtons of thrust is not going to help you, but it's going to be a lot more than a gravity tractor.
Well, we've done some quick calculations based on the duty cycle and that maneuvering around, and it's not clear that it's better than the gravity tractor
For what size are you talking about?
for a 200 to 300 meter class target asteroid with a given boulder size of, say, 20 to 100 tons. So I'm just saying that there are a lot of factors. Certain assumptions will lead you to one conclusion. Other assumptions will lead you to another conclusion. Because we have not done an apples-to-apples comparison, I think that this statement is actually fairly accurate.
Yeah. Stan, can you go ahead?
It's-
Where we just go ahead. I'm just turning it on. I think you're.
Is that better?
Yep,
There we
yep.
go. So just based on the text on the slides, I think, based on the previous comment, that you can demonstrate the ion beam deflection with the ARRV vehicle just by swiveling it back and forth. It's going to be a pain in the butt, but you don't have to change the design of the thing, and you're only going to have a less than 50% duty cycle plus maneuver time. But you can demonstrate the concept. And I think that as it stands on the slide, I think we've said what we want to say. Now, what I'm hearing is a lot of debate about which method is best.
Right.
And I don't think it's our duty to decide that. I think the statement that we're going to compare the relative effectiveness, risks, and applicability, and let the engineering studies sort out which is best, I think the statement we have is good based on that.
And I have no problem putting ion beam deflection first if that at all helps. I mean, that was just how it got typed in last night, so.
I'd say it's alphabetical right now. Go with it.
Okay.
Yeah, Dan, I think we need to stay kind of agnostic about the solution. So I would suggest maybe say consider it as valid concepts and then drop this first sub-bullet, likely to be lowest cost demonstration. But the next sub-bullet comparison is certainly exactly right.
Okay,
we
so
have
how
valid
about
concepts.
innovative, valid
Yeah,
concepts?
yeah. And then the lowest cost demonstration, I think that's to be proven. I think we might all agree with that, but what is the lowest cost? I don't think that adds any value to the point. The point is we've got more work to do on all of these.
Yeah, well, I mean, the issue here is we had
Lowest cost
three different
comparison to what is
classes.
kind of my issue.
Yeah,
Yeah, that's the point.
the point is,
Compared to.
right, and if you look at the next finding, other demonstrations that don't affect the ARV, such as kinetic impactor with the ARV observing at the large target NEA, at a large target NEA, are recommended if budget permits. So that is an example of an additional cost, because if you do bring in kinetic impactor, that's going to be an additional spacecraft that has to be costed.
Yeah, but
So-
again, I'm not sure that's more or less expensive than a kinetic impactor that's augmented with, that's using the ARV as a kinetic impactor with augmented mass.
Okay.
I think that's in a kind of a different class than the gravity tractor or the ion beam. It may be in a different class. So, I
Okay, so comparison of
relative effect.
cost, how about add cost into here,
Okay,
and then strike this bullet,
there you go.
unless
Yeah.
there is something, and we were trying to make the point that if we use what we have, and I can do it verbally, if we take advantage of the equipment and the development and the fuel that we have, then that's going to be the lowest cost thing
Yeah.
to do.
But again, we're talking about relatively small increments here,
Right. So,
so.
Okay, just
We
a
good
time
with
check. It's getting close to 9:30. so-
yep. So I went ahead and stated the second one. I kind of hate having single sub-bullets, but at this point, I don't really. Thank you. I'm an engineer, not an English major, and I do that all the time. Okay. So here on this second one, I try to capture the discussion yesterday that, and Bon Wee and I had a little bit additional discussion, and I got a comment there that I can delete, that demonstration of a nuclear device is not compatible with the ARRM mission, both budget, schedule, et cetera, programmatics, all of the issues associated with having something nuclear in the program. I think we can all agree that that's probably not something that we want to do. However, some of the hardware and operations needed could be tested. For example, testing of a blended kinetic impact and subsurface nuclear explosion as proposed in the HAIV concept could be done. So the point is that we don't necessarily, if someone wants to have something that's tested as part of another approach that we can't actually do a demonstration mission on, that we could accommodate that. Whether we want to or not, that's another issue. So I'll throw that out for the floor for discussion.
Well, the first sentence basically says we're not going to do a nuclear demonstration, and the last sentence implies that you might do a nuclear demonstration. So I would reword the last sentence to make it clear that you're not actually using a nuclear explosive in the test. But
And subsurface.
right, I mean, it basically says "and," yeah, right. And however, I would recommend you just stay with the first bullet and drop everything else, because you really don't want to get into the business of even appearing to promote the idea of a nuclear test, because the issues of the Nuclear Non-Proliferation Treaty, China and Russia both want to violate the treaty to get testing time on their weapons, and we do not want them to get testing time on their weapons. So this is a huge foreign policy issue, and for a group like this to come out and even appear to be moving in the direction undermines the policy of the United States.
Okay.
I just want a very quick comment based on your suggestion. But yes, I agree with you, everyone feeling about the sensitivity issue. So that the phrase needs to be sort of modified. So all the concept we are currently studying is not to have actual flight demonstration using the black box device. So somehow we have to rephrase that. We will need to test everything except nuclear warhead. So we clear now? So that needs to be changed. All the concept, all the mechanism, timing, except the nuclear testing.
Right, and that was the point
Yes,
of this,
uh-huh.
and considering the fact that we have a NIAC, NASA-sponsored NIAC study that's exactly doing this,
Yes,
that
exactly.
advocates, I mean, you could say we've already violated international whatever. We haven't done it because we actually, I mean, we haven't violated anything because we haven't
Yeah,
done it.
we haven't violated anything. We don't have to worry about.
That is the difference.
Can you use the microphone, please, sir?
So that's the difference. NIAC is.
No, you have to use the microphone.
They can't hear you online.
So that's the difference. NIAC is a study. This is not a study. If you guys are advocating going to do this, then we're actually going to take hardware somewhere and do something with it. That is a problem. I think that you should drop everything from however down.
Okay.
Just drop it and you're fine.
Yeah,
Okay.
that's okay. That's okay.
That's fine.
Yeah, that's absolutely fine.
Jim, I completely understand that sensitivity.
Oh, then that is very misleading. Then this group is denying the availability, that option. Look at the demonstration, it's not, it's not comparable, but demonstration of all other kinetic impact, guidance, navigation, technology, timing issue, everything needs to be flight tested.
Steve, can you go?
I think that the hardware and operations can be tested without, as an example, for ISIS, I've been talking with the Lawrence Livermore people who really would like to put a radar ranging timer on the spacecraft as a test, so
Right.
that they can determine whether or not they can trigger at the right time with enough confidence. And so that's a technology that really doesn't have anything to do with nuclear. So I think maybe the last sentence could be struck, but the middle one about however some could be tested is fine. For instance, testing timing and ranging devices is a big deal for these kinds of problems.
Yeah, I mean, that was my feeling during the discussion, that, I certainly understand the sensitivities to the whole nuclear issue. However, we may find that it doesn't work, that and that it's not an option. So therefore, that's good to know, that we have to invoke something other than a nuclear approach to solve this problem. On the other hand, we may be presented with a short warning time impact where that is the only option. And I don't know, I think the nations of the world will come together and say, if we needed to do that, we would do that. So that's my personal opinion. I don't want to be a dinosaur. So
I guess if you leave Steve's second sentence in here, I think you want to take out the word device. Demonstration of a nuclear planetary defense capability is not compatible with this mission, but we could demonstrate some hardware or operations. When you say device, I think that next sentence opens you up to all kinds of trouble.
capability?
Yeah.
Okay. I knew this would be a hot button topic here. I knew it, but it was like, okay. Everybody, and again, I'm fully appreciative of all the comments here. I mean, this is a sticky subject.
So,
Can you get closer, Jim? Thank you.
He's the microphone pit bull.
so I don't know if this is, I understand the intent of what you want to be able to include in this, but in the context of what we're trying to do, with international collaboration options and having this really be about human exploration and maybe science and planetary defense as secondary objectives, you're opening up a can of worms by even saying you're going to allow for testing of some hardware. There's a big difference, again, between studies like NIAC, where it's just a study, and saying that we're going to consider this. I actually think it's going to cause problems with support and continued efforts.
How about this? How about studies to identify? No?
I think it's fine.
Fine, yeah.
You're going to cause all kinds of problems.
So,
This is the planetary defense session, right? So,
Yeah, my propose would be that we are offering this to the plenary session, now and then let them make a decision at that point. And maybe I move this bullet like to the very end, so we can get through everything.
Could I just make a suggestion here that's of a different nature? How about however the results of some of these arm tests might provide insight into those capabilities? Because that's really what we're talking about here.
No, we're talking about specifically putting, you could, if you wanted to expend the budget, to put, like Steve said, some timers, understanding of that impact that would be above and beyond what we would normally do for an impact, because now we're just trying to hit it. Here, we're trying to understand the physics of the surface collision, the penetration into the surface, the timing of all that, which is an important part of a subsurface kinetic impact or hybrid.
Okay. Yes, so that, I think, would get you into problems pretty quickly. I mean, think of the ITAR on that, nothing else.
I agree with Steve. This is a planetary defense, so let's take it to the planetary and let other people.
Well, I would like to second what James said, that, it's true that Livermore and Los Alamos would like to do this. There are people in the trenches there that would love to have, be able to work on this, but, the State Department is going to kill all this if we put this in.
That's why we take it to the plenary and let the decision makers.
Yeah, I mean, again, I think this was a request, an international request for ideas, and that's what we're supposed to put forward. And James, I think you're okay with sending this to the plenary and letting them?
Yeah, it represents what is being brought forth in the RFIs. It does not necessarily represent what will go forward out of the plenary.
Right.
So it'll get killed, but that's okay.
That's fine.
Hey, Dan, I think we're making... 7 years ago, we did a study where I put 7 W-82 warheads on the Ares 5 and published it. There's a video out there, and the world didn't end. We're still here. And you know what? I didn't get a call from the State Department. I didn't get a call from DOE. I didn't get anything like that. We did a pretty good modeling program. We showed a lot of effectiveness there. Nuclear is an option. The Europeans are not going to be happy about talking about nuclear. They never have been. But in general, this is an option that has to be discussed. If we're talking planetary defense, we're not talking nuclear at some level, then we're taking out a large ability to defeat the threat. So, I mean, I really don't see the State Department throwing a fit. I don't see any of these other things happening.
Okay.
Stan, go ahead.
Go ahead, Stan.
Second to last.
Okay.
Yeah. Okay. So
The State Department, if the State Department wants to shut it down, that's their job, and let them do it. But this is a technical solution that needs to be discussed for planetary defense.
Okay. All right, so
let's move on.
Let's move on.
Short in time.
Okay, the next one I think will be okay, but there may be a little word change that we need to do. Robotic spacecraft mechanisms in support of planetary defense efforts, for example, surface sampler, pneumatic sampling and excavation, snare system, self-opposing multi-mode anchor, could be used or evaluated, maybe that should say or, during ARRM if additional cost can be shared or is acceptable or something like that. I put shared just because trying to minimize cost. Any problems with I don't know if it has to be, well, shared is, it can be 1%, 99%.
Before self-opposing, shouldn't that be or instead of and?
Sure. Okay, and there's a sticky coming in.
Okay, we have 2 comments from the Twitter universe and Ustream. Mike Helton, NASA needs to identify 2 families of asteroid deflection, one to avoid impact and one for capture and science investigation. And I think some of that we were already talking about.
Yeah, I think we've got that.
And then from a Ustream comment is first is study, then is consideration for test, then is utilization. So just in terms of, so I think we can probably address both of those in what we have here.
Yeah, I think those are good comments, but they're pretty germane to what needs to be done. Okay, so findings relevant to Grand Challenge. Many demonstrations, such as solar collector and use of in situ materials for mass driver or propulsion, could be important to addressing, and I left off the kinetic impactor. I can't believe I did that. Well, because we had already covered it before. So, but let me. I'm going to put it back up here because it is the number one according to the NRC report, and I'll put an or here. Could be important to addressing the grand challenge, but may impose additional constraints, for example, cost, schedule, etc., on the ARRM that are unacceptable. I don't know if the word unacceptable is unacceptable, but these constraints should be analyzed in more detail given the wide range of ideas and uncertainty in how or if they could be accommodated on the ARRM. And these ideas could be pursued if additional funding is available. So this is to capture, everything that I mean, as much as I'd love to test out a 50-meter solar collector and zap an asteroid with it to see how effective it is, we've got to bear the cost, and unless there is some cost sharing. But then there's also an effect on the flight system that has to be looked at.
Well, don't test a 50-meter, test a 5-meter.
Yeah.
So, I mean, a 5-meter solar collector would be so incredibly small here. It's hard for me to accept the unacceptable statement here because, I mean, you're talking probably something on the order of 300 kilograms. I mean, that would be a fraction of the ARRM, and there would be a lot of advantages to having, that as part of the test program. I mean, with the capabilities that the solar collector brings to the table, I just think, it's a good demonstrator.
Okay. So is it acceptable to remove the unacceptable? Does that read all right to you? That just they impose additional constraint?
And just drop the R and make that a may as well. May prove unacceptable, And put back what you had there. That may prove unacceptable, just as opposed to the R.
Well, but
I understand that, but,
My objection is to have the solar collector in this bullet because, I mean, of course, that's what I'm going to say, but I just don't see that as being a hard thing to do. I mean, good grief, I could go take NanoCell and redesign it and meet the time and cost constraints and have this be a small demonstrator mission where we see if we can nudge this asteroid around.
Yeah, but right now in the ARRM, there is not a solar collector, there is not a kinetic impactor, and we actually, for the alternate approach, we were asked by headquarters to defer the impactor for right now because of cost reasons. Anything that's additional to the program, I got a double may here now, may impose that may be unacceptable.
So if it's not already on the ARRM, then it adds cost and schedule to the ARRM. But the ARRM is kind of an arbitrary baseline in the first place.
Absolutely, and that's the whole point of this RFI, is to see if there are ideas.
Except, I thought that the point of this slide with the title is to take the ARRM out of the equation.
Well,
is that not true?
Well, the point with this is saying that if it's unacceptable on the ARRM, they are still important for the grand challenge. That's the intent.
So why are we kind of using the ARM as a litmus test here on this
That's
slide?
the reason why they're falling into this category, because we didn't think they fit under the ARM findings, but we want to make sure that they're captured. So I could just, we could just strike this.
Under the grand challenge as a program, these are things that are worth investigation.
Yeah, and I'm fine with that if we just want to do that.
Well, Dan, instead of doing that, why don't you put another bullet on there saying, there's recommendations from the room to reevaluate the ARRM.
Okay, so let's do. Whoops.
No one likes that one. Huh?
I think what Steve said is probably right. It eliminates the confusion. I know that's what we were trying to do, is trying to make it so that these were captured under the grand challenge and not relevant for the ARM.
How about this? I think we've captured it there. in the sub-bullets. It says they should be looked at to see if they could be accommodated in the ARM, and they should be pursued if additional funding, it could say additional funding or cost sharing is available. They could be guest payloads.
That's fair. I'm a little confused why the ARM is, like gentleman here said, the litmus test. It's a study that was done in a couple months, and it seems like there's, why is this the gold standard?
Well, so rather than focusing on the specific design of the current ARRM baseline, think about it at a little bit higher level. The purpose of the mission is to demonstrate, whether we agree with the purpose or not, the purpose of the ARM mission is to demonstrate that somebody can collect a large quantity of asteroid material and bring it back to the vicinity of the Earth in a controlled way. So some kinds of asteroid defense demonstrations are compatible with that, and others, like a kinetic impactor or I think the solar collector, are potentially viable asteroid defense method, or
But they're less compatible.
are potentially useful asteroid deflection mechanisms, but they're not things that would work as means of bringing back an asteroid in a controlled way to the Earth.
I totally disagree with that.
Maybe I can nip this in the bud,
Yeah.
because right now, planetary defense is not a primary objective of the asteroid redirect robotic mission.
Right.
Okay, so therefore, this was included as, again, a request for ideas to see how maybe that objective could change. There's a lot of discussion right now as whether it should be a primary objective or it should remain a secondary objective. That decision has not been made. So at this point, again, the call in the RFI was particular for the ARV, so the ARRM mission. It was not specifically to the grand challenges.
All right. Well, like I spoke yesterday, the solar collector, a 50 meter, is more than capable of pushing a 6-meter asteroid through a delta V of a kilometer a second. So
absolutely,
pushing a small asteroid into high Earth orbit is totally within the solar collector's capability. So I think it could be a retrieval mission, whether it's an add-on to the existing one or if it's one by itself, is another question.
Yeah. So I hear you absolutely.
Right.
If this was formulated differently, and if we were in the capture system or the redirect system, which actually happened on September 30th before we had the break. If someone was proposing using a solar ablation technique for redirecting, that could be a viable approach.
Right.
There's issues with that.
Well, since the last gentleman said that he didn't think it was useful for redirecting an asteroid into orbit, I just wanted to emphasize that I totally believe
it definitely could be.
Right.
Hey, we have to move on, so stand real quick.
Piece, I think as it stands, it addresses the last concern we heard.
Okay, so let's move on. We only have 10 minutes.
Yep. Okay. I think this might be easy, but I just want to capture these nuggets, and I can remove these. These are, they're not necessarily asked for, but I try to capture a couple of suggestions or thoughts that struck me that may have some applicability. Howard suggestion to off-point solar arrays to provide high bandwidth communications using the Astro Array concept. I don't know that we can do anything like that with the Megaflex, but that was kind of a nugget that I thought, because we're, depending on the mission profile, high bandwidth comm would be very helpful, and we may have some pointing constraints. That's just an idea. So again, that's why I call these nuggets. Comment on that? Good. Howard's not here, so I guess we can go forward. Andy's up at the microphone, but I had put down, I'll just read it and then you can comment. Andy mentioned the concept of having SEP thrusters on booms so that some thrusters can be rotated to perform the IBD demonstration more efficiently. Could require more thrusters.
It's not what I said.
Not what you said?
No. What I referred to, I'm just going to say what I was saying, and then we'll have to rephrase it.
Okay.
It's up there. What I was saying is that the way we build our spacecraft today, which have electric propulsion, we have thrusters on two sides of the spacecraft. They're actually mounted on arms, not booms. Okay. But anyway, so that arm is short. Okay, boom is long. Okay, they're on arms. No, there is a big difference. There's no deployment of the arms.
Sure, sure.
So they can, the two thrusters can be directed in the same direction, what we call aft on our spacecraft.
Right.
Okay. Then we can rotate them 90 degrees so that one can point, in the way we fly them, actually one points north and one points south, because we're doing north-south station keeping in geosynchronous orbit. So we can, the way our spacecraft are built today, we can push in both opposing directions.
Right.
So one of our spacecraft, the way it's built today, could be used to, it has the right geometry for the ion propulsion to be used.
Okay.
For the
So-
ion beaming.
so-
So the way we should rephrase that is that you can, like you said, you got arms. So if you're requiring more thrusters, that, if you're going to include that phrase there, I'm not sure that's the case, because you will probably have multiple electric thrusters anyway, right, for your ARV.
Okay.
Yeah, that would be fine.
Okay, no
What
problem.
I had envisioned is the way we fly our spacecraft today is we have 2 thrusters, and you probably would have 2 or some higher number anyway.
Yeah.
Okay. So
Yeah,
let's
we're running on 3 with one spare, so
Okay.
that doesn't, you know,
That
necessarily
doesn't
make
hurt.
sense.
That doesn't hurt.
Okay.
Okay, so
All
let me look at it one last time, because I think you almost got it. Yeah, that's okay.
Okay. This is a concept that's come up many times, came up again, separable spacecraft concept to provide operations near a larger near-Earth asteroid, or I could just say a large.
The one thing that to me is sort of missing here is the notion of having thrusters on arms is already a TRL. Maybe you put this in somewhere else, but it's TRL 9 because we already do it. It's not something new you have to develop, putting thrusters on arms. Okay.
How about
Heritage arms.
How about I'll just put it currently
Currently
TRL 9.
Currently TRL 9.
Okay.
Yeah. Okay.
And again, I don't know if I'm going to read through these nuggets, but I wanted to have them available. The possible, so again, separable spacecraft, we've talked about that many times. It could be desirable, particularly for the large one. It could be desirable for the small one too, but it's an additional cost that would have to be looked at, and complexity, rendezvous or re-rendezvous, et cetera, et cetera. But I think that's a nugget. Possible use of Earth-Moon L4, L5 points as long-term storage locations for use of ARV plus material for future kinetic impact demo or actual planetary defense. I think Jeff Landis was advocating that we would actually keep it there and potentially use it. Whether or not that's realizable is another thing. Tim had the suggestion of leaving mass close to the NEA for the pick up a boulder. I called it pub approach now, because I think I want a beer after when we're done with this. But I think that has some potentially interesting merit. I don't know, keeping that mass close to the body could be beneficial. It adds complexity. It could reduce operational risk by keeping the spacecraft further away. Might introduce other operational risks.
I would say tether/boom.
Short tether/boom. Well, no, we definitely need a boom here. Okay, and then again, I thought John Brophy's comment about via Andy Thomas' suggestion to use the IBD to slow down the spin of a small sub-10 meter size NEA to improve capture dynamics is.
It's actually Andy Thomas via Brophy.
Okay. I mean, I was just trying to give credit to Andy, parenthetical. Via my. Okay.
Why don't you just say
Circa?
Andy Thomas?
How about circa? Per Andy Thomas?
Yeah.
Okay, there you go. Thank you. CubeSat to provide a low-cost transponder to test tracking capability for future monitoring of hazardous. Thank you. It's even red. Transponder to test tracking capability for future monitoring of hazardous NEA. Again, I think that's a good idea. Can we afford it? The ISIS kinetic impactor could be a very low-cost approach for demonstration on ARM. If it's been built already and we're flying another one, then it could be. I think, and Steve said that. And that's it.
Do we have any more? No. Okay, we're good.
Wow, okay. I didn't think we were going to get there, but what do y'all think? I mean, you know, in general, do you think we've captured what's been discussed here? I know there are dissenting opinions on some of the subtopics, but okay. With that,
I think our chairs deserve a hand.
thank you. And I'll put that right back to the whole group. I appreciate everything that you guys did, and Jonathan for capturing this morning, and I didn't thank Pedro yesterday to the group, and Pedro for capturing the online feed. And again, thank you to everybody that joined us in the ether, in the cloud. We appreciate it, and thanks very much.
And thanks for our AV support.
And thank
as
you to
well.
the AV folks.
Thank you.